factoring polynomials by taking out the GCF. Let's factor this polynomial by taking out the GCF. This is from a problem we looked at earlier. I just turned it into a real problem with the signs. So our first step will be to find the GCF. So from our numbers, we will use a 10. From our variables, we'd have to take the lowest exponent, x squared. And we could not take a y because there is no y in the first term. So we find our GCF. We're going to pull that out of all the terms, and it's going to go on the outside. We're going to make one big set of parentheses. Inside the parentheses, you will have as many terms as your original problem. And we're going to go term by term and see what would have to multiply by the GCF to get back to the original problem. So this parentheses will be the missing part. Right, so first for our first term, we have 10 and we want 10. So we're good. We don't need another number. We have x squared, but we would like x cubed. So we're going to have to multiply by an x to get back there. For our next term, we have 10. We'd like to get a 20, a plus 20. So we're going to need a positive 2. Just divide if you get stuck for the numbers, because 10 times 2 is 20. Right? The x squared, that's what we have outside, and that's all we want. So we don't want any more x's inside. Right? We also want to get a y inside, but we don't have any on the outside, so it will need to be here. Then we're going to multiply by something to get our last term. So we have a 10. We would like to get back a negative 40. So we're going to need to multiply by a negative 4. And then for our x's, we have x squared, so 2 x's, and we want 4. So we're missing 2 more x's. Also, we want to get a y squared, and we don't have any y's, so the y squared will need to be here. Right? This is now a product, so it is factored. To check, we will multiply it back. So for our check, we're just going to distribute. So we will have 10x cubed. Remember, the exponents add when you multiply. And 10 times 2 is 20. X squared y. And 10 times negative 4, negative 40. And x squared times x squared will give us x to the 4th. And a y squared does match our original, so we're good. Now your answer is this line, your factored form, so it needs to be a product. Let's look at some other examples. So for this one, we're going to factor 3m plus 12. First step is find the GCF. So you look at your numbers and try the smallest one. 3 does go into both, so we can use a 3. We cannot do an m because the second doesn't have an m. So our GCF is a 3, goes on the outside, one set of parentheses. You'll have 2 terms in the parentheses because you have 2 terms in the original problem. And then you'll put the missing parts on the inside. So we have a 3, but we would like 3m. So we're missing an m. We have a 3. We would like to multiply and get a positive 12. So we need to multiply by a positive 4. You should check on these because the check is fast and it's easy. You can even do it in your head. To check, you would just distribute back. So 3 times m gives 3m, and 3 times 4 gives 12. Let's factor this problem. 9x to the 6th plus 27x to the 4th. Step 1, find your GCF. So for our numbers, we will actually test the lowest. The 9 works. It's going to divide into 27, so we'll take a 9. For the variables, we have to go with the lowest. We'll go with x to the 4th. That's our GCF, goes on the outside. One set of parentheses. And to get back there, term by term. So first for the 9, we're good. We have x to the 4th. We want x to the 6th. So we would have to multiply by an x squared. To get to our next term, we have 9. We would like 27. So just divide. You need a factor of 3. And we already have all the x's we need outside. So our check, 9x to the 6th plus 27, x to the 4th. So to factor this polynomial, our first step is find the GCF. We can try the 8, that smallest number, but it's not going to work this time because it doesn't go evenly into 12. It would go to the 16. So we're going to have to go smaller than 8. So how about a 4? A 4 would divide evenly into all of those. So we can take a 4. Then we try our variables. We're not allowed to use an x because the last term has no x. And then for our y's, we do have y in everything. We have to take the lowest exponent. That's our GCF on the outside. One set of parentheses. And now to get back there term by term. So we have a 4, would like to get 12. We need to multiply by 3. We need an x squared. And we're good with the y because we have it outside. Next term we have a 4, we want a positive 16. So you need to multiply by a 4. You're going to need an x to get an x here. And you have one y, you want y squared, so you need one more y. For the last term, you need to multiply by a negative 2 to get the negative 8. And you're good with the y. It's on the outside. And you should check on all. So distribute back to do your check. I want to go back for just a moment. And I'm going to work this problem incorrectly. I'm going to miss something and show you what happens. Let's say that I didn't actually see the 4. Let's say I only saw a 2 for the number on the GCF because 2 is common. 2 goes into all of those. So we'll pick a 2. I'm not going to mess it up too bad. Let's go ahead and keep the y. And so to get back, we have 2. We want 12. We're missing a 6. We're missing the x squared. We have the y on the outside. For the next term, we have 2. We want a 16. Just divide. So we're missing a factor of 8. We want 1x. We don't have any, so we need it. We have 1y. We want y squared. So we need one more y. And for our last term, we have 2. We want a negative 8, so we need a negative 4. And our y is okay. We have it outside. Now, if we check this answer, it's going to work. So if you distribute, you're going to get 12 x squared y plus 16 x y squared minus 8y, which puts you back at the original. The problem is this is not factored completely. Inside, you left a common factor. And your clue here is that all of these are even. So it's partially factored, but it's not completely factored. You could fix it from here by taking out the 2 now, and it would multiply by your 2 on the outside. Or if that's too messy, you could just start over. But it's not finished. It's not factored completely. So you always want to try to find the GCF.